Mr. Wright here, and welcome to this run-through of this Edexcel Maths IGCSE paper from November 20. If you'd like to download a copy of the question paper, then you will find a link in the description. Hit the link, download the paper, and you can have a good go at the paper before watching the run-throughs. This run-through is in two parts, so there are two films. The first film for the first set of questions and the second film for the rest of the paper. And at the end of the second film, you'll find a short film of me letting you know what the grade boundaries were for this set of papers to enable you to work out what your grade would have been had you sat these papers. If you find this film useful, please do hit like, give me some positive feedback. If you've got any questions, do leave them in the comments, and of course I'll respond. And if you are preparing for your Edexcel IGCSE Maths exam, you might do well to subscribe to the channel. Right, good luck with the paper. Question 13. We're investing $8,000 in an account and it pays a mystery rate of compound interest. So that means I don't know what the multiplier is going to be. I'm going to assume that the multiplier is going to be y. At the end of 6 years, there's that total. Okay, so I can set up an equation here. I know that 8,000 multiplied by my multiplier to the power of 6 gives me 8877.62. Divide both sides by 8,000. And now I know what my multiplier to the power of 6 equals. I'm just going to write down all the digits on my calculator here. That is my multiplier to the power of 6. Find the sixth root of that. Tells you that my multiplier is 1.017500022. Right, so it looks like then if that's the multiplier, then the interest rate x must be 1.750022%, because that's what it's increased by every year for 6 years. And it asked me to find x to 2 decimal places, so my answer is going to be 1.75% to 2 decimal places. Question 14. F is inversely proportional to the square of v. So that means I can write that f equals k over v squared. Great. Now, given that f is 6.5 when v equals 4, find the formula for f in terms of v. So let me substitute in the values I know. So if f equals k over v squared, then 6.5 must equal k over 4 squared, k over 16. We'll multiply both sides by 16, and now I know that k is 104. So now I can rewrite my formula. Instead of writing f equals k over v squared, I can write f equals 104 over v squared. And there is my formula for f in terms of v. Question 15. Harry has two fair 5-sided spinners, spinner A and spinner B. Okay, he's going to spin each spinner once. So it looks like he's doing spinner A first and then spinner B. Complete the probability tree diagram. Right. On spinner A, by the way, the probability of getting a red is 2 out of 5, isn't it? And the probability of getting a green is therefore 3 out of 5. Right, so spin A, probability of getting a red, 2 out of 5. Probability of getting a green, 3 out of 5. Good. Spinner B, probability of getting a red is 4 out of 5, isn't it? Look, 1, 2, 3, 4. So probability of getting a red is 4 out of 5. So probability of getting a green is 1 out of 5. 4 out of 5. 1 out of 5. So that is my probability tree diagram completed. Now, what's it going to ask me? Work out the probability that at least one of the spinners will land on green. At least one. So that's going to be this outcome, red, green, that would count. This outcome, green, red, that would count because at least one of them is green, and this outcome would count as well, green, green, because at least one of them is green. So in fact, all the outcomes are going to count except this one. So I'm going to work out the probability of red and subtract that from 1. Now the probability of red, remember you multiply as you move along, is going to be 2/5 times 4/5. So the probability of red is 8/25. Now all the other outcomes have at least one green, don't they? So the probability of at least one green is 1 subtract the probability of them all being red, which is going to be 17/25, and that's my answer for this part B of the question. Question 16, circle theorems. Right, so you're given some information and you're asked to find the size of angle MLP. MLP is this angle here, isn't it? Well, I can see a cyclic quadrilateral there. NMLP is a cyclic quadrilateral, and opposite angles of a cyclic quadrilateral add to 180. So MLP is going to be 180 minus 58. 180 minus 58, 122. Give a reason for your answer. Well, my reason would be opposite angles of a cyclic quadrilateral add to 180. Find the size of the reflex angle MOP. That MOP is going to be what's the reflex angle? So what's this one? I'm going to do that by finding this angle first, because I know that the angle at the centre here is double the angle on the circumference. So that angle MOP here is going to be double 58, 116. So MOP, the reflex angle, is going to be 360 minus 116, which gives me 244. And that is the size of the reflex angle MOP. And that is that question done. Question 17. A metal block has a mass of 5 kilograms correct to the nearest 50 grams. So that means that the mass is 5,000 grams, but if that's correct to the nearest 50, then the upper bound is 5,025 and the lower bound is 4,975 grams. And the block has a volume of 1.84 times 10 to the minus 3 cubic meters, and that's correct to 3 significant figures. So the upper bound would be 1.845 times 10 to the minus 3, and the lower bound would be 1.835 times 10 to the minus 3. Work out the upper bound for the density, giving your answer in kilograms per cubic meter. So density is mass divided by volume. We want the upper bound of the density, so we're going to want the highest possible mass and the lowest possible volume. But I'll need to use mass in kilograms so that I get my answer in kilograms per cubic meter. So the mass is going to be 5.025. and the volume, the lowest possible volume, 1.835 times 10 to the minus 3. Put that in my calculator, and I get 2,738.41 and so on. So to one decimal place, that's 2,738.4. And that is question 17 complete. This table gives information about the heights in centimetres of some plants, and we need to draw a histogram. Right, so I'm going to need to know the class width. So from 10 to 20, and so on. So here are my class widths, 50 to 70, and 70 to 80. And now my frequency density is going to be the frequency divided by the class width, 35 divided by 10. 45 divided by 15, 75 divided by 15, 40 divided by 20, 8 divided by 10. And so now I'm going to draw the histogram. I'm not going to make you watch me do that. I'm going to pause the film and draw it, and then, hey presto, it will appear done. There you are. As if by magic, my histogram is drawn. Not very well. I hope you've done a better job with your pencil and ruler. Now, part B, work out an estimate for the number of these plants with a height greater than 40 centimetres. Right, so I need to know how many plants appear in my histogram with a height greater than 40. Well, I know that there are 8 here, and I know there are 40 here, and I know there are 75 in this block as a whole. Well, from 40 onwards, that's 2/3 of the 75, isn't it? So that's going to be 50. So my answer is going to be 50 plus 40 plus 8, 98. And that is question 18 on histograms finished. I've got 6 over 3 minus root 7. So I'm going to multiply top and bottom by 3 plus root 7. Okay. So on the top, I'm going to have 6 3s are 18 plus 6 times root 7. And on the bottom, I'm going to have 3 3s are 9. The middle terms are going to disappear, minus 3 root 7 and plus 3 root 7. And then I'm going to have minus root 7 times root 7, so minus 7. So that's going to give me 18 plus 6 times root 7 over 2. Well, that is just 9 plus 3 root 7. Question 20, similar shapes. So we have shape R here, and we have shape S. Now, surface areas, how do they compare? Well, shape R has a surface area of 108, and shape S has a surface area of 300. So the areas there, if I do 300 divided by 108, the areas have a multiply factor of 25 over 9. So that means that the linear scale factor is the square root of that. So the linear scale factor is 5 over 3. So the volume scale factor will be 5 cubed over 3 cubed. Now let's go back to the information in the question. It tells us that shape R has a volume of 135. And it asks us for the volume of shape S. So that's going to be 135 multiplied by 125 over 27. And that gives me the answer 625. And that is question 20 done. Question 21. Right, I'm going to deal with the multiplication first. So I'm going to ignore that. Minus 7 over x minus 1. Okay, so I've got 1 over 3x minus 2 multiplied by, now this is the difference of 2 squares, so that's going to be 3x minus 2 times 3x plus 2. And that is over this expression here, which can be factorized into 3x plus 2, which conveniently will cancel, multiplied by x minus 5. Now let's multiply these two algebraic fractions together, cancel that with that, cancel that with that, leaves me with 1 over x minus 5, from which I have to subtract 7 over x minus 1. So let's write those with a common denominator of x minus 5 multiplied by x minus 1. It's going to give me 1 times x minus 1 minus 7 multiplied by x minus 5, which is x minus 1 minus 7x plus 35 all over x minus 5 lots of x minus 1. So let's simplify the top there. Minus 6 x plus 34 over x minus 5, lots of x minus 1. And I suppose if you wanted to, you could factorise the top, if only to illustrate that you can't do any more cancelling. Let's have a look what will come out of there. 2 will leave me with 17 minus 3x all over x minus 5, lots of x minus 1. And there you go. Question 21 complete. Question 22, we've got a rhombus, and it tells us that diagonals intersect at a point M. The other thing I know about the diagonals of a rhombus is they cross at 90 degrees. So let's draw a rhombus so we can have a look. Well, when I say draw a rhombus, let's draw something approaching a rhombus. So we've got diagonals of AC and BD. So here's AC, and here's BD, and they cross at 90 degrees, and they intersect at M, and the coordinates of M are 6 minus 11. And it tells me that A and C lie on this line, 2y plus 7x equals 20. And I'm asked to find the exact coordinates of the point where the line through B and D intersects the y-axis. So I'm going to need to find the equation of the line that runs between D and B. I'm going to need the equation of that line. So I'm going to need a point on the line. Well, I already know that M lies on the line. And I'm also going to need to know its gradient. I don't know the gradient of dB, but I can rearrange this to tell me the gradient of AC. There we go. So the gradient of AC is minus 7 over 2, and dB is perpendicular to that. So the gradient of dB, the m of dB, will equal the negative reciprocal 2/7. So now, as far as dB is concerned, I've got a point on the line, I've got the gradient, so I can work out its equation. Y will be 2/7 of x plus c. Let's substitute in the values that I know. Minus 11 equals 2/7 times 6 plus c. Rearrange that to give me c is minus 89/7. So the equation of dB is y equals 2/7 of x minus 89 over 7. Now, what does the question ask me about that line? Find the exact coordinates of the point where it intersects the y-axis. Oh, well, x is going to be 0 when it crosses the y-axis, and y is minus 89 over 7. So that is the point where the line that goes through B and D intersects the y-axis. Question 23. It looks like I'm going to need to differentiate here because I'm asked to find the range of values for which the gradient of C is negative. Now, if y equals px cubed minus mx, then the gradient function, dy by dx, equals 3px squared minus m. And I want the values of x which make that gradient negative. So I need to solve the inequality. The gradient has to be less than 0. So I just need to solve this. Okay, so 3px squared must be less than m. So x squared must be less than m over 3p. So that's going to mean that x has to lie between the negative square root of m over 3p and the positive square root. So that is my solution. Question 24, we're dealing with an arithmetic sequence. We're given the first 5 terms, so I know the first term is 8, and the difference between each of the terms is 7. And I've got to work out the sum of all the terms from the 50th to the 100th. So what I'm going to need to have to do is I'm going to need to work out the sum of all the terms up to the 100th term. And then from that, I'm going to subtract the sum of all the terms up to and including the 49th term. And that will leave me with the sum of all the terms from the 50th to the 100th. Right, the sum of all the first 100 terms will be 100 over 2, multiplied by twice the first term, plus 99 times 7, because that's the difference. And on my calculator, I get 35,450. And the sum of the first 49 terms, 49 over 2, multiplied by 2 times 8, plus 48 times 7. And on my calculator, I get 8,624. All right, so the sum of all the terms from the 50th to the 100th will be 35,450 minus 8,624, giving me an answer of 26,826. Question 25. We're at the end of the paper. The curve with equation y equals g of x is transformed to give you y equals minus g of x. Oh, well, it's been reflected, hasn't it, in the x-axis. So it's reflect in x-axis, I suppose you could say, or you could say in the line y equals 0. Okay, the diagram shows the graph of y equals f of x. Okay, on the grid, draw the graph of y equals 2 f of x minus 1. Right, well, let's first of all think about just f of x minus 1. That's going to move the whole curve 1 unit to the right. So that would move it here, and it would move the points at which the curve crossed the x-axis 1 to the right as well. So that's the first stage. And now we've got that curve, but what we really need is twice that curve, 2 f of x. Now, if the values of y are going to double, well, when y was 0, which is here and here, it's going to stay doubled. Sorry, it's going to stay at 0, because double 0 is 0. And when y, for instance, here is minus 3, it's going to become minus 6. So my curve is going to come down here. That's the minimum, and then it's going to go, up there without the wobble. And that is question 25 done, and that's the end of the paper. Well done.
Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries, and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel, and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel, and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.